Come on, YouTube. You can do it. All right. In theory, we're live. Hey, Casey, how's it going?
Very well, and how are you?
Good, good. I guess we talked. It was a couple of years ago, actually. Last time we chatted, and a lot of the things that we talked about are well on their way. So it's kind of interesting to sort of do a catch up on the conversation that we had a couple of years ago, as Starship was still a sort of hope in Elon's eye, and now here we are, them mostly not exploding. I guess they're mostly exploding. Some are occasionally not exploding. But who are you? Just for people who don't recall our last conversation, who are you? What do you do?
Yes, to those of your listeners who have remained blissfully ignorant of my existence, my name's Casey Handmer. I'm a PhD in physics from Caltech. Sometime in the last decade, I work at JPL, which is a NASA center in Los Angeles. But of course, here and in my other appearances online, I speak only for myself. NASA has many professional communicators whose job it is to disseminate the official point of view, and they're very happy for us to go off and share our enthusiasm and excitement about this sort of stuff. But I have to be very clear that the cost of that bargain is that I'm officially some guy on the internet with an opinion.
Right.
So that's what we're here for.
You're blogger, Casey Handmer, not NASA JPL developer.
Well, if it makes your listeners feel better, very few people at JPL take my opinion seriously either. Officially, as well they shouldn't. But I've only been there for 3 years. I'm still a new guy.
Just shut up and code. All right.
If only.
Yeah. Cool. So, man, all right. So I'm just going to start with the idea that you proposed that kind of blew my mind. And so I want to dig into this, which was you have a radical idea on how to deal with space junk. Powdered sugar.
Powdered sugar. Yeah. That's an old one. It turns out it's one of these ideas that is such a good idea. Someone else had it a long time before I did.
Yeah. Okay.
And in fact, it's a variant of the idea has been patented by, I think, the Office of Naval Research or something. Man, it's really complicated and technical. It's kind of hard to explain, but because it's like natural intuition for these subjects is very hard to develop, or very easily. People are very easily led astray. But I suppose, generally speaking, for every 100 kilometers further up you go, the space junk lasts for 10 times longer. So, something that's thrown off the side of the space station might deorbit in less than a year. But if it was 100 kilometers higher, it would take 10 years. And if it was 200 kilometers above the space station, it would take 100 years. And very quickly you start to run into thousands and tens of thousands of years and so on. And meanwhile, the available space for things to be in, grows a bit, but not nearly as quickly. So the odds of having kind of a chain reaction of collisions goes up. And by the time you're at 1,100 kilometers or so, which is the altitude of the Iridium satellites and really the highest density of space junk, stuff up there can stay up there for a very, very long time. And it's a real worry. I mean, it's not quite the same as the movie Gravity, as much as I love that film.
Right.
And and like even in the ultimate worst case scenario, you could still operate satellites. You just have to operate them, fairly close to the Earth, where there's not as much space junk because it all gets deorbited by the atmosphere, which is kind of one of the good things about the ISS being in such low orbit. We do have to reboost it all the time, but at the same time, there's less space junk than there might be if there's still enough to give them the odd bad day, but there's less space junk than otherwise. And so the reason that the amount of space junk kind of drops off as you get closer to the Earth is that it gets swept out, particularly smaller, lighter particles. So if you think of something like a plastic bag, not that there are plastic bags floating around in space, but something like a plastic bag has a lot of surface area and not much weight. So it just kind of gets swept along by the wind. Something like that would get deorbited very quickly, whereas something like a shot, like a cannonball or something, has a lot more density and a lot less surface area. So that would be capable of staying up for much longer, or alternatively orbiting for much longer at any given altitude, or alternatively orbiting stably at a lower altitude than any others. And in fact, there are some more or less radical proposals for satellites that are basically like long, thin spears of dense metal that are able to orbit at extremely low altitudes because they don't have much drag relative to their momentum. So all this was kind of percolating around in my head. And the challenge with space junk is not so much that there's no way to fix it. There are plenty of ways of fixing it. The problem is that you want to find a way that's where the cure is better than the disease. And so, for example, some ideas where the cure is maybe not as bad as, the cure is worse than the disease, would be things like setting up lots of like space shuttles to grab big chunks and bring them back down, which is actually something that the space shuttle was kind of designed to do in the first place. But the space shuttle was never able to fly up high enough to get the Iridium satellites down.
Sure, but still, a $1 billion mission to retrieve a dropped astronaut glove seems right. If every piece of space junk that you want to retrieve is on its own special orbit, you need to match that orbit.
Yes.
And so you know, at the very cheapest, you're looking at a tens of millions of dollar grabber robot on top a $60 million Falcon 9 launch. You're looking at $100 million plus just to grab your one piece of space junk, and then this whole apparatus comes back to Earth, and then you pick your next target. 100,000 to go.
Yeah, well, there's a lot of space junk up there. I think the aim of the game would be, if you were doing individual missions, would be to try and grab the big dead satellites and deorbit them before they turn into lots of smaller pieces. And actually, sometimes dead spacecraft just disintegrate anyway. Like, they have an explosion or they start to spoil paint chips and stuff like that. So like old stuff in space tends to, gradually fragment. And you want to grab those big bits and take them away before they can, start feeding this cascade of smaller and smaller particles. Then you could imagine, some ground-based laser system that shoots these things and either blasts them into little pieces or potentially applies some photon pressure to them, which changes their orbit enough that they get close to the atmosphere and burn up. You can imagine, swarms of small CubeSats that can kind of have electric propulsion, so they can do quite a lot of orbital maneuvering and grab things and then suicide burn them into the atmosphere. You can imagine things with nets and sticky wires and stuff like that. The problem with all these ideas, as cool as they are, aside from the expense, which is obviously incredibly high, relative to the value that can be directly captured by pulling a satellite out of orbit, unless a government is prepared to hand over $N billion a year to do it.
Yeah, all of it.
Which means taking it out of someone else's pocket to do that in a way, is that it's the sort of technology that makes the other spacefaring nations kind of twitchy. And necessarily they would also have to develop that sort of technology because of balance of power and proliferation and stuff. And we've seen this in the past when the Soviets went and built a space shuttle for no good reason. They just knew that the US had one and therefore they'd better have one so that when they worked out what it was for, they wouldn't have to then start again from scratch. So yeah, I mean, like anti-satellite technology is one of those things that generally speaking, everyone involved doesn't really want to be like, yes, we should do more of this. Yeah. So with all that in mind, I was kind of thinking about this problem and as other people obviously have come up with the same idea. What if you could take these larger chunks of space junk and increase the drag that they experience so that they deorbit more quickly? And you could think of that as like a skydiver ordinarily can fall at a few hundred miles an hour towards the Earth, but they release a parachute. It increases their surface area, which increases the drag, which lowers their terminal velocity, which causes them to land, survivably. So you need something like a parachute. It turns out that there are multiple ways of doing this. But the way that really appealed to me was, what if you put, more space junk up there, but this space junk was of sort of an intermediate size. So like this space junk was, it's kind of ballistic coefficient, or it's like mass to surface area parameters were relative to the air molecules, the same as the space junk was relative to these new particles you put up there. And so instead of having a situation where you've got a cannonball, barreling through space where it hits, a couple of atoms a second, which does absolutely nothing to it in terms of drag, it's instead plowing through this stream of particles. You could think of like a big dispersed cloud of sand or something. and that transfers a lot of momentum, because when big things hit little things, that it transfers a lot of momentum, and then all those little particles of sand then go and disperse and smash into all the air molecules. And so you can think of this as what's called a kinetic cascade, but basically a mechanism that enhances the transfer of energy from the very large dense particles into the air. There's a bunch of different ways of thinking about it, but that's the basic idea. And so in terms of the execution, then you need to find particles that have this maximize the momentum transfer on impact. And so if you think you're little hard balls, you could get 2x the momentum transfer. But actually, if you have little particles that actually vaporize and then emit superheated gas, you can get like 20x, because it turns out that the kinetic energy at the closing velocities of stuff in space is so high, you can quite easily turn basically anything into a superheated gas. And this should be intuitively obvious to anyone who's looked at the stuff that comes out of the rocket nozzle that gets it into space in the first place. The energies involved are kind of high. And so you can actually get about a 20x factor of momentum transfer, which is great. So you get 10x extra for free. And then you want something that is reasonably biodegradable, because these things are all going to end up back in the atmosphere again, and they're not going to burn up because they're so light and fluffy. They'll actually be able to radiate heat faster than the atmosphere is, heating them up as they re-enter. And so actually, we've seen this before, where like, if a satellite re-enters and breaks up on re-entry, little bits of Kapton and Mylar and like other fluffy stuff can kind of rain down to the surface intact, more or less. You can pick up little pieces of paper with names and stuff on it. Whereas the really big, heavy, dense things, well, if they sometimes they make it through the atmosphere, like the engines and stuff like that. It's a bit of a crapshoot, to be honest, what makes it and what doesn't.
Yeah.
But that is a concern for people who are designing satellites to be safely deorbitable. And so there actually has been a precedent of in the 60s, I think, of launching like millions and millions of little copper wires to try and increase the radio reflectivity of the near space environment. And they're actually, because they're metallic, they got electrically charged from impacts of reasonably low energy electrons from the sun. I believe that's the case. In any case, they got charged and they all stuck together, which undermined their efficacy somewhat. So you'd want to try and like put in some kind of anti-caking agent, so they'd all kind of disperse nicely. And a few other bits and pieces. And I basically was looking around, I was like, okay, and now I need to find something that's on the order of 50 micron size, which is about half the thickness of a sheet of paper. Standardized, preferably light elements, because you get an enhanced momentum kick. And so you're talking like hydrogens, oxygens, carbons, rather than like tungsten or lead. Although intuitively you would think that something like lead or tungsten, because it's higher density, would work better. But actually, when it comes to launching, you care more about mass than about density. And also I want to be able to obtain it, reasonably cheaply in 20-ton lots, because I'm going to fill up, the SpaceX Falcon 9 the payload fairing with it, and just like then pressurize it and then release it, and it's just going to kind of everywhere. And so it's all very well to be like, oh well, we'll build a custom ball mill for this, very fancy borohydride pyrophoric material that needs special handling and stuff, and we'll have to build it at the Pepcon plant or something outside Vegas and hope it doesn't do what it's done before. And then I was like, no, actually you can buy confectioner's sugar like in container-sized quantities very, very cheaply, and it basically meets the bill, icing sugar.
Right.
And I have to say that this is not an idea that I've subjected to peer review, so your listeners should should not take it on faith. But I think it'd be a fairly extreme step to take. But if it was a necessary one, I haven't yet encountered a way of doing it that would be cheaper or sweeter.
Right. Well, but you needed an anti-caking agent, and obviously this wouldn't fit the bill on that one because it's definitely a caking agent. But would it render space unusable for a while the icing sugar cloud is deorbiting all the space junk?
Yeah, put some icing on the cake.
Yeah.
So there's actually some really nifty things about this, and there are papers out there that people can read about this. Again, it's one of these things that I was like, I wonder if someone else thought of this. Oh yeah, people have. But essentially, if you can pick the size of the particle and thus its orbital lifetime, and you can tailor that quite quite precisely for the target orbit. So say you're trying to deorbit debris from Iridium satellite collision, which is one of the major clouds of space junk. It's in a polar orbit. They're all processed. It's all over the place. And say 50 microns is the right size. It goes up there. And all that stuff, because these particles are so small, will deorbit within a year. So you know right away that, so even if it's a terrible idea, you only have to wait a year and the problem's gone away. But the other thing is that it sweeps material ahead of it. So like space junk that's smaller than a certain characteristic size will be swept ahead of it and will continue to be pushed down into the atmosphere as the whole cloud with this stuff that it's sweeping kind of contracts around the Earth. But it's stuff that is beyond some critical threshold size, whatever that is, and that can be tuned, will experience collisions and some slowing, but will be left behind. And so the cloud will be there, and then the cloud will pass by. So, for example, by the time the cloud gets down to the orbit of the ISS, yes, it will. The cloud and the stuff that's in the cloud presumably has the potential to impact with surfaces on the ISS, which are designed to withstand micrometeorite impacts of this scale anyway. But will only be in that kind of region and that density for a reasonably short period of time. And by reasonably short period of time, I mean it's like this is not an ideal thing. No satellite operator is like, oh yes, I would love to have a whole bunch of volatilized like organic compounds flying around in space. Sign me up, Handmer. But as an alternative to having tens of millions of hypervelocity chunks of steel flying around up there or aluminum, there's obviously a choice to be made there.
Yeah.
Violate the spirit, if not the letter, of the Outer Space Treaty. But ultimately, like these things, it's not like some rogue state is going to be like, aha, I will sweep all your space junk out of. It's actually like, well, we've got a serious problem. We have to do something about it. So,
is the problem that people have been launching satellites too high? I mean, isn't Starlink, kind of onto something with launching their satellites very low, and then letting them clean themselves up after the fact? I wonder if how much of the work that satellites get done these days could be done just at low altitudes.
Yeah, it's certainly looking that way. I mean, in the early days, if you wanted to launch a constellation that covered the whole Earth, you would go into a higher orbit because it basically costs the same. For low Earth orbit, between 500 and 2,000 kilometers, it's all the same. But if you're further off the surface of the Earth, you can see more of an area. So like the Iridium constellation only needed 66 satellites to cover the entire Earth, whereas the Starlink is much lower altitude, needs many more satellites. And I think the initial plans for Starlink were at higher altitude for that reason. But then, obviously, there are all kinds of good reasons to go to lower altitude. You need less signal power. You have a higher density of customers because the beam focusing is less. And then you can also have a situation where if your satellite suffers critical failures, you don't have to deorbit it. You can just run it until it literally won't go anymore, and then it will deorbit. And actually, one of the nice things about the Starlink design, I believe, is that it's reasonably low drag provided that it's oriented, but if it loses control, it tumbles and then it increases its drag a lot. And then, as we've seen actually in the orbital tracking of the Starlink satellites that were DOA, they didn't stay up for very long. And they're also launched into very, very low orbits. So if they don't even turn on, they just fall straight back in the ocean within a couple of weeks.
And when you think about every single satellite application that's done today, weather satellites, Earth observation, GPS, television broadcasting, it feels like all of those applications would be better served at lower altitudes. Like each one of them would do its job better if you could get more satellites at a lower altitude, which ironically would be safer for space junk purposes, for us sending people into space and other things. This is my thinking. And then, you're looking at some of these ideas like these air-breathing ion engines would allow you to lower your orbits even further, that you could bring these orbits down. And I've seen estimations that you could bring orbits down to 200 kilometers. You're in the middle of the atmosphere this whole time, but you've got this air-breathing ion engine that's pushing. It's using solar energy. It's pushing against it's sucking in atmosphere, using its thrust, and it's maintaining some perfect balance. And the second its thruster goes off, it burns up.
It doesn't even make an orbit. Yeah.
Yeah.
I'm not convinced Avery and the ion engines. I haven't read much about them recently, but last time I checked, I was like, that seems like a fairly long bow. But actually, just to come back to your previous point, GPS satellites generally operated at mid-Earth orbit, I guess. They're in roughly 12-hour orbits.
Yeah.
And then you've got the geostationary satellites, obviously, which are 24 or 23 hour, 56-minute orbits. And they, especially like the weather satellites that are out there and so on, and the TDRS constellations and later constellations, stuff like, they represent a different business model and one that has worked extremely well. And when the GPS satellites were going up in the early 90s, like that was kind of the way to do it. If you have a situation where launch is cheap and available and satellite technology is cheap and available, then I think you can make an argument that, for the next generation of GPS, we could do it with 10,000 LEOs, CubeSats that do something or other, this, that, and the other. It's very, very clever stuff. There's a few papers floating around out there on this sort of thing now, but it's still very, very, very conceptual stuff. And I wouldn't expect to see that anytime soon, because the people who are responsible for building and operating these systems have specific mission needs that are met by their current configuration, and they're not particularly cost sensitive.
Right.
Whereas, and actually in many ways, being all the way out in geo is a good place to be if you want to make it hard for North Korea to shoot you down,
right.
Or something like that.
Yeah.
Although there are I'm not telling tales out of school. That you can some fabulous YouTube videos and stuff from the Chaos Communications Conference or whatever, people who set up telescopes to look at the various geo satellites that are doing sneaky things up there.
Yeah. I've got a photograph of the Rosette Nebula with that Dylan O'Donnell took with star trails passing through it, because the Rosette is perfectly positioned for geostationary satellites to move right through the field of view, and so those are the satellite trails that you get through your nebula.
Damn you, Elon.
Yeah, it would also solve the astronomy problem as well, because these things would be so low that they would be in shadow almost instantaneously. So I think we can solve a lot of problems. Why won't anybody listen to me? Anyway, now last time we talked, I want to shift gears here. Last time we talked,
sure,
you made the bold assessment that there's no possible way to make money in space, and that anybody who tries is going to lose everything.
Did I say that?
Well, you said something like, space power, asteroid mining.
No.
Yeah. That there's nothing like that isn't just like Earth serving Earth. There's no
communications
way.
And observation. Are like demonstrated business models.
Yeah, and so when people say that
navigation PNT.
You could mine an asteroid and take $10 trillion and crash the world economy, blah blah blah. And then since then we've watched since last time we talked, we've watched various companies attempting to monetize space struggle and fail.
I don't take any pleasure in
no.
Or whatnot. Kind of failing and parting out. Although a few of my friends did pick up some of their workshop machines and they've gone on to have another good life, which is I guess encouraging in some ways. Like essentially venture capitalists are indirectly providing fancy machine tools to hobbyists who know what they're doing, but would otherwise have no ability to access them. I get asked about this stuff fairly frequently. I don't know why, because I'm sure these people know what I'm going to say, but anyway, they say, "Oh yeah, that's right."
Yeah, well, it seems like I guess my question then is just like, has anybody come up with an idea that has changed your mind, or is it still space is the place is like worse than buying a sailboat? Just a hole in the universe.
No, it's
that
a good
money
sailboat.
Into.
Yeah, no, I mean, since we last talked, I've kind of been obsessed with Zeppelins, and I've been thinking because Sergey Brin's trying to build one. Yeah. And I think they're freaking rad. Like I 3D printed one. I can pull it out if you want to see it. But the problem is like everyone's like, oh, we did one today. We could make it with carbon fiber, and we could use helium and stuff, and it would cost $500 billion, but it would have 10 times better performance than the Hindenburg, and it might not explode.
Oh, sorry. When I say buying a sailboat, sorry, a sailboat is a hole in the ocean that you dump money into.
Oh, yeah, I understand.
Yeah.
I grew up playing around on them.
Right. And so
we can find a way to
and a space.
Zeppelin,
No, and
$1 million or less, then actually you can start saying, well, like, people can build these in their garage, like a very big garage.
Right.
But they can build them for sort of yacht money as opposed to like national security money. And then people can just like punt around in the sky in a Zeppelin, and if they get struck by lightning, well, bad luck.
But I'm just saying that just space in general as an economy is a place in the universe that you dump money into. Right.
Yeah. And I think
space mining, space power,
various billionaires, try and do, various projects in space that are more oriented towards, showing off one way or another, or prestige, than trying to find an adequate business model. And I think, Elon, by his own admission, got into this thinking, I'm going to do a philanthropic mission. I'm going to spend $80 million and grow a plant on Mars. That was his original goal. And I guess, well, they've made some progress, but they still haven't landed anything or even launched anything to Mars. And actually, I think the Chinese just landed something on Mars. So, better get on with it, Elon.
Right. Well, the Chinese grew plants on the moon, so they took his idea.
They grew a pea plant on the moon. I think it's probably fair to say that they independently developed that idea. I don't think that they just copied Elon, that guy.
Yeah.
They would actually do well to copy Elon when it comes to booster recovery, I think. My scalding hot take on that whole Chinese booster coming down to burn up is just like, well, dropping boosters on random parts of the ocean has gone out of fashion in the last 10 or 20 years. But actually, if I was the Chinese, I'd be like, well, it'll be like moderately nice to the international community to figure out a way of deorbiting this in a controlled way, but actually be far better to figure out a way of deorbiting it and landing it back at the spaceport so we can use it again, because people have been able to do that for 6 years now, and we still can't. What are we doing? So that's keep your eye on the prize. Let's raise the scope of our ambition. Now, in terms of wasting money in space, I've looked in a lot more detail at lunar stuff recently because of the HLS contract and that sort of thing. So I think it's probably a fair criticism to say I'm jumping on the bandwagon. And I think the really exciting thing is that we actually have a credible path to doing space stations and doing moon bases and Mars bases for kind of thousands to tens of thousands of dollars per person per hour or per day, as opposed to tens of millions of dollars per person per hour. And this is one of the things that kind of put me off a bit about the HLS protest. In Dynetics and the national team were like, oh, there was some problem with the way this contract was procured, which of course there may be. And that's not my, it's beyond my pay grade to decide that. It's also completely within their rights to protest this, and it's a standard practice in the industry. And I get that. But on the other hand, let's look at what Bezos is best known for and what made him famous and what made him rich. It was his unerring instinct that the customer is always right. And in this case, NASA is the customer, and they've made it crystal clear that when one of their 3 bidders came along and said, actually, what you asked for is silly, we're going to sell you another rocket for 1/4 the price that has 10 times the capacity, and no, we won't water it down for you. You can take it or leave it, and we're building it whether or not you give us the money.
Right.
NASA said, actually, that sounds like a really good thing. Thanks. And then, I can understand that Bezos should be upset that someone else's rocket will be taking humans back to the moon before his. But that's water under the bridge at this point. Looking forward, doing stuff in a more let's do this super cheap and we're just going to maximize tons per year and minimize dollars per ton. Yeah, that's the right way around. Maximize tons per dollar means that the pie just got a lot bigger for everyone, right? And so it's no longer a question of well, sorry, Boeing, you didn't even make the first cut, which is what cost Doug Levera his job, right? Boeing is back in the game because if Boeing and Lockheed and Alenia Space, whatever the tail is, the Europeans and the Japanese and Blue Origin and all these other contractors can now think about not having to solve the $5 billion, oh shit, I need to build a rocket development program, but they're oh, all I need to do is build or borrow an enormous space simulator and then just start getting space hardware developed, and then suddenly have a reason to recruit really, really smart people straight out of college who would otherwise have no choice but to work for Elon at SpaceX or Tesla. And Caterpillar, for crying out loud, should be beating down Elon's door saying, please, 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 please don't verticalize in like the automated mining and like giant trucks sector. That's ours. We don't want you to ruin it for us. Like Komatsu already almost did. We'll just give you the rover for free. Then suddenly all these people can have their hardware driving around on the moon in a couple of years, and they don't have to worry about like, oh, we're going to make it out of titanium that we've milled to a 5 thou thickness so it's light enough to fit on the spacecraft. They can just take the standard commercial stuff, put on some space grade paint, upgrade the electronics a little bit, and just focus on like executing, building something like an Antarctic station on the moon, rather than some like dismal tuna can like the Jamestown base in the first season of For All Mankind. So that's my scalding hot take on all that.
Right. Well, so we're like a couple of weeks now after SN15 has flown and landed, and as I mentioned, not exploded, which was quite exciting to see. Not yet. Yeah, no, I know. I keep saying that. People keep
now
saying,
have to figure out how to get it off the pad.
It didn't explode. It hasn't exploded so far.
What are they going to do with it? All the others have the decency to just like disperse themselves so they can make room for the next one.
That was very convenient. Yeah, it was like they needed a surprise crane. They needed to bring in a crane because they didn't know what to do at this point. No one was expecting it.
Have you seen that crane they're building? My God, it is like so big.
So, I mean, now I guess for their next trick, they need to demonstrate that they can return from orbit. And that is the game changer, right? Like up until this point, you're blowing up stainless steel grain silos in Boca Chica. But if you take this thing to orbit and you return it from space, and both the Super Heavy and the Starship land successfully, and then you start putting cargo on it, can anybody compete with this?
Yeah, I think so. So there's two things there. The first is if they can get to orbit, that's already transformational, right? Because like even if it takes them another year to figure out how to get the Starship back and land it reliably, or 2 years, say, just being able to get 200-300 tons up there expendable on a Starship platform is huge. It's huge. It's like you want a space station to replace the ISS with its 600 cubic meters of usable volume. Well, here's a burned out booster with 4,000 cubic meters of volume. Sorry, we can't make it smaller than that. Per launch. And the thing is, like, SpaceX is like, well, we can't do this affordably without making them reusable. But why not also make them cheap? And they figured out how to make them cheap. So they're able to make the Starships, I think, for less money than they can make the Falcons. So they're probably able to offer expendable launches on these things for $50 million, which is, I mean, like, that's their internal cost. I'm sure they'd charge other people more.
Yeah.
But like maybe even less. I mean, like, I'd say it's probably around 10 million. It's hard to say at this point because, a lot of these costs are very front loaded, but like the overall unit cost is about $10 million. They can get these things to orbit. They can probably get, a secondary, like a third stage payload on something like this can easily get, anywhere in the solar system with a somewhat smaller payload. That in itself is transformational. However, if you want to land a Starship or use a whole Starship to take cargo elsewhere and land it on the moon or land it on Mars, you have to do refueling or refilling of oxygen and fuel in low Earth orbit. And I don't think that's really, I mean, you could do it once or twice without reusability, but I think you'd have to be able to rely on reusability to kind of scale that in a meaningful way. And of course, there's also commensurate reduction in cost when that's available, but it would be, like, you can certainly get started without that being totally dialed in. There's still enormous utility, and for SpaceX, that it's like, all right, we'll just put up another 400 Starlink satellites, put up another 400 Starlink satellites. Try again.
Yeah. Right. So they launch 400 Starlinks and then attempt to retrieve the rocket, and if they fail,
that's right,
then they still made a few $100 million in profit from the additional coverage.
Or they launch a prototype lunar Starship and just leave it in space with people on board for a while and see how it goes. Or fly astronauts up there for the Dragon and see how it goes. Test out all the systems because the in-space environment in low Earth orbit is a lot more like the surface of the moon than Boca Chica is. So I think that's, I think it's pretty exciting. it's certainly encouraging. I think when they set out on this program probably 5 years ago in a public sense, 4 or 5 years ago, they were attempting to identify and retire like the key elements of technical risk. And I think that they've basically done all of that. At this point, there are TRL9 solutions available for all the stuff they haven't yet demonstrated. Some of those are expensive. Some of them are a pain in the ass. I'm sure they're trying to find cheaper, better ways of doing them. But even if they can't, even if it's impossible, even if tomorrow they figure out how to innovate, they can still like go and build the damn thing.
Right. But I mean, but then if they do retrieve these things from space, if they can make them successfully re-enter the atmosphere and land again, so that's almost just icing on the cake at this point.
I think it's very much necessary as part of the long-term.
Sure. Yeah.
Long-term plan. Yeah.
Yeah, but it's not necessary to make a transformation in the way stuff gets put into space.
Yeah, I just don't think. I think that there'll probably be failures in attempting to bring back the orbital booster, and it'll probably take a while. And I think there'll be a couple of people who'll be very quick to hang a failure sign around the neck of SpaceX and be like, it'll never work. It's failed. It hasn't failed. Like, if they can get this thing to orbit, which at this point I think is probably in the bag. I mean, like, I don't knock on wood. I don't think everything that they need to put this into orbit, they do almost every week already. That in itself would be, pretty transformational. But yeah, if they can get it into orbit and bring it back, that's another thing entirely.
Elon Musk has said that the current Starship is sort of like the minimum size to make this concept even work, and it gets even better the bigger you make them.
Mm-hmm.
Is there a limit to how much rockets the world needs? Like, could they eventually just make one rocket and just call it a day?
No, I think there probably is like a happy medium somewhere. Ultimately, when you start thinking about, well, we need to get 1 million tons of cargo on the surface of Mars, probably the practical limit is how quickly you can build and roll out launch facilities on the surface of the Earth, because Pache, like, I think you could probably make an argument that you could have launch facilities in places other than eastward facing near equatorial coastal areas, if these things are as reliable as they need to be to make this worthwhile. But they still have to be in reasonably isolated locations. And it still involves a lot of concrete and a lot of local procurement of fuel and oxidizer and logistics. But yeah, you can imagine launching a couple of thousand of these a day. I mean, prior to COVID, tens of thousands of commercial aircraft flights in the United States every day. And if you kind of just penciled out, we're going to build a Boeing 737 or an Airbus, and of course, we're just going to fly them over cities and like put them down on, we'll just make a long skinny strip of asphalt and it'll come down and take off. It'll be fine. No worries. Sometimes the wind blows the other way, but we can figure out what to do. People will be like, I think you probably better do that, like, a long way away.
Yeah.
But, we've got it down to a science now. And so I think you could make an argument that Starships could be flown a similar way. Actually, so I just remembered you asked before, are we in a situation now where no one else can compete? And the answer is, no. I think that, and this is again something that kind of, when I'm thinking about like, what does Blue Origin do now? I'm reasonably sure that like New Glenn is not really in production. Like, I don't know for sure, but I'm willing to bet that like they've got a mock-up in that factory, but they haven't actually got the tooling necessary to build these at any kind of rate. They don't have the technicians trained. They haven't solved the technical problems. This thing is still a long way away from being put up at the launch site and launched into space. And even if it wasn't, it's now reasonably clear, in the same way that this was a great idea 5 years ago and SLS was a great idea 20 years ago, that, its day has passed, really. But this is not necessarily bad news for Blue Origin. There's many other problems that need to be solved between now and when Starship becomes fully operational, and will now have an absolutely unsatisfiable craving for cargo that it can like put into space. The other thing is that like,
so they could just put new Glens inside Starships and fly them.
Well,
to
I mean, but like space stations, for example, like it seems reasonably clear to me that Elon is not that interested in building space stations, but someone has to. Why not? And Blue Origin seems to think that's a good idea. But one of the amazing things that SpaceX generates, in addition to all these cool rockets and stuff, is a constant stream of ex-SpaceX employees who are like withered, burned out husks of their former self, but know all these amazing things. And so really anyone who wants to compete with SpaceX has to do is wait until the Starship design is more or less finalized and the kinks have been worked out of the system, and then go and hire half a dozen people who built it and be like, make me a copy.
Right.
And then they don't have to live with the early design mistakes that were made that SpaceX had to work around. So they can like clean sheet design, fix all the problems they wanted to fix the first time around. Obviously being careful to avoid putting in too much extra stuff. And B, they don't have to bear the $5 billion development cost, right? All they have to do is be like, we'll just copy that one.
Mm-hmm.
And I make it sound simple. It's not simple, but it's a lot easier than doing it for the first time. And at that point, I think you could plausibly see a lot of other entrants come into the space, particularly given that, we now know that the cost of building these really giant rockets is not necessarily any higher than building a smaller one. Mm-hmm. And the really expensive, hard, long lead items are the really high performance rocket engines, but they're only necessary if you want to do single stage return from the surface of Mars back to Earth, which is not everyone's cup of tea. So yeah, I think that we'll probably see like SpaceX have a couple of cushy years where there's not much in the way of competition, but then I would be very surprised if the Chinese and the Russians at any length didn't copy it straight away, and the Europeans eventually get around to realizing that something has changed.
Mm-hmm. Yeah. Well, the Chinese actually, there was a mock-up. I don't know if you saw this. There was like a Chinese state rocket company posted mock-ups of their Starship clone already. So that's the only one we've seen so far from any rocket company at all. And, they haven't even really perfected the technique of, they haven't at all perfected the technique of reusable first stages, even though they're starting to make their first stages look very similar to the Falcon 9. They could very well be just trying to skip and go straight to a Starship version. But I think you're right. I mean, if it turns out...
We'll have to see. I mean, like, it's a long way from, here's a picture of what we think it might look like.
Yes.
To we actually have, hardware that can achieve the desired reliability.
Somebody draw me a Starship and make it look a little different. Yeah, no problem, boss. This, perfect. That's what we're building.
Yeah. I mean, just like any other country, like there's an awful lot of dreamers in China, and all power to them, but they're also just as clever as anyone else at doing mock-ups and CGI and stuff like that. So you have to be paying attention to really kind of deduce whether the serious greybeards are involved and doing stuff, and where the kids who've got some seed money are like, oh yeah, we could build this maybe. So we'll just have to see what actually gets launched.
So then I guess, what do you think? And like, it feels to me like Starship is such a dramatic change, or even just this revolution of big launchers bringing launch costs down below $100 a kilo, possibly down to $25 a kilo. Like, it's going to be kind of ridiculous. And so you can imagine the low-hanging fruit, 42,000 Starlinks, anything NASA's ever wanted to send into space, a bunch of tourists, maybe you send a few colonists on Mars, and then you bring them all home, and they apologize to their families for ever wanting to make that journey. But do you run...
No, they work there, and they're like, this is sick.
This is,
recruit all my friends and family, come out here.
Oh, sure, maybe.
Live with me on Mars. Yeah.
Well, I don't think so. I think they're going to be like, I wish I could see an ocean again. Oh, right, those are
Let's
on
make
Earth.
an ocean.
Yeah, maybe, just terraform Mars.
Exactly.
But do you think that we run out of payloads at a certain point, or do we get the... I mean, I'm sure someone was thinking like, who's going to want to, airplanes. I mean, there's only 10 things that people are ever going to want to fly on an airplane. We only need 10 of them. Is there a need?
Things to fly on airplanes came along really fast.
Yeah, I know. So
immediately recognize utility.
Yeah.
Like, I just realized the other day, like, there wasn't a commercially successful airliner until the DC-3, which flew in 1936, I think, or maybe 35, 4 months before the Hindenburg actually did. So it's like this weird, like, small overlap of like aluminium planes and aluminium or shiny airships. And actually, the Hindenburg was the first commercially successful airship as well, for at least long distance passenger transport, up until the last flight.
Yes.
But it had about 100 successful voyages before then.
I had no idea. 100.
Yeah, it didn't do a Titanic.
Yeah.
Yeah, I think it operated for 2.5 seasons or thereabouts. It did flights between Germany and Newark, and also Brazil.
I would totally fly in a
Yeah,
not
me
a
too.
Hindenburg, but in a blimp. That'd be fun.
Yeah,
I'd love that.
make a really, really big one. So I've been thinking about this a lot recently as well. And I think if you say, well, the only thing that can go in a rocket is a JPL developed Mars rover that costs $3 billion to make, then pretty quickly you saturate demand. But I think that we're highly likely to see that there's a lot of induced demand, and in fact that it's highly elastic, which is to say that modest reductions in cost have a greatly increased demand of flights, or I should say, like a lot of business models that were previously marginal become possible and then get funded. And obviously, like there's a lot of work here for capitalism to do in trying out ideas and spending money and training people up and developing ideas and trying things out. But one of the things that I've been kind of pitching for a while is this idea that we should just dedicate a Falcon Heavy or a Starship flight to every planet in every launch window. Like if a launch window comes around, the Starship's going. If it's empty, it goes anyway. And then it just like put stuff on it until it's full, and then it off it goes.
Right.
And then that way, you start thinking about exploration programs of Venus. Mm-hmm. Who here has ever heard of Venus? Mercury, Venus, the Moon obviously will have programs anyway. Mars, and then the outer planets, various asteroids, whatever. Like we're basically talking about 10 launches a year, which the Falcon Heavy would be about $1.5 billion a year for all those flights, just for the transport.
Right.
Which is actually reasonably modest in the context of the sort of money that gets spent on space exploration anyway. And then all the different program scientists and engineers and so on would be thinking about this in terms of a campaign, which is one of the things that made the Mars exploration program at NASA so successful, is that there was always, the next rover and the next helicopter and the next lander and the next orbiter to think about. And so all the contractors and engineers and technologists and so on who are developing these instruments would be able to say, well, we'll fly this instrument now, and then we'll have another one ready in 4 years for the next one, and then another one, and we'll propose another one. And so they're able to kind of build this like multi-generational expertise and really deliver incredible science and value for money. So what I'm saying is take that idea and turn it up to 11, every single planet, every launch window, send 100 tons, no questions asked. And if your mission, if your instrument is not ready, it's okay, it goes next year.
Right.
Doesn't matter. And if the rocket blows up, doesn't matter. You go next year.
Yeah.
And you can 100 tons. You want to send 10 rovers, send 10 rovers.
Yeah.
One of the problems that we're facing here is that.
Yeah.
Yeah. So I was going to say one of the problems we're facing here is that traditionally speaking, JPL has had a business model, and much of NASA's had a business model where they do these big directed flagship missions that Congress says, go and put me a rover on Mars this decade, and they spend $3 billion, and that helps to fund, the 5,000 engineers and specialists and technologists and technicians and so on who are necessary to make something the size of an SUV that weighs less than 1 ton, so it weighs about a third as much as an SUV, and it's got these absolutely incredible instruments, and it's powered by plutonium, and it has a laser beam eye and a helicopter out the side, and it generates oxygen, and it might have a X-ray spectrometer and a mass spectrograph and all kinds of fancy stuff like that. And essentially, if you say, hey, NASA, can you make me something that's a tenth as good for a tenth of money? You say, no, we don't get out of bed for less than, X billion dollars to do these flagship missions. And we can produce 1 ton per decade of flagship mission, and it will cost you $1 billion. And now we say, well, actually, we're going to be launching 100 tons a year. So that's 1,000 tons a decade. And the cost of each launch is, say, $10 million, $100 million, something like that. So actually, we want you to reduce the cost of what we're launching from $1 billion per ton down to $1 million per ton. Now, $1 million per ton is 1,000 times less, but it's about the same cost as a Ferrari. So you say, well, how is it that Ferraris are so expensive compared to a Toyota Camry? And the answer is everything in a Ferrari is, hand built and hand designed, and there's a hefty, profit margin on top of that. But everything is kind of hand tweaked and hand, machined, as opposed to being mass produced by a robot. So how do you get from $1 million a ton to $1 billion a ton? Well, you say, well, every time we go and build a Ferrari, we're actually going to burn up all our books, hire people who know nothing about building cars, and they have to research internal combustion and oil and gas extraction from the crust from scratch.
Right.
It's kind of the sort of money we're talking here. And that's actually a real problem. And I'm not convinced that NASA as a whole has really come to terms with this. I'd say it's not guaranteed, but it's a high percentage probability at this point of being at the point where its business model evolves and it has to be able to produce quality science instruments and vehicles for $1 million a ton instead of $1 billion a ton, and to send them all. And so like that's a higher cadence of production and it's a lower unit cost. And it just means like the way of building these things looks a lot more like a Ferrari factory, really, frankly, than JPL for all its amazing.
And I've definitely thought about that if you do bring the launch costs down, you bring the launch cadence up, then you have to move towards some kind of basic platform that you then connect all of your various instruments on top of. But you've got a very standard bus, you've got a very standard propulsion system, solar panels if it's going to be in the inner solar system, an RTG if you're in the outer solar system, and then you mix and match the kinds of scientific instruments that you're going to want. But it's a very known machine that then gets iterated on every couple of years. It's interesting to me.
Yeah, for sure. So you can imagine having a Mars rover, but instead you have a production line of them, and you're always building one for the next launch window, or 10 for the next launch window. And this is a big high bay at JPL. I don't see any reason why you couldn't have 10 rovers under construction at any one time. You just have to have common tooling and build something more than once, which is they're currently allergic to. I think one of the really attractive things about this is that instead of having to have a few hundred mechanical engineers spend all their time and effort trying to work out how to make this thing and shaving off tenths of a gram everywhere, right? Like the rover's a ton, so tenths of a gram is 7 orders of magnitude less than that, and that's kind of where they're tracking masses. Instead, you can devote all that engineering ability, which in any organization is a finite resource, to doing other things. Mm-hmm. You could improving cost, not caring as much about mass, improving performance, improving cadence, improving reliability, improving capabilities. And I think this is actually the place where a lot of commercial partners can come on board. So again, like companies like Caterpillar, Halliburton, Bechtel, other enormous professional engineering companies that typically specialize at a slightly lower point when it comes to like the price point of what they're delivering. Still well out of the price range of average consumers like you and me, Fraser. But they work for commercial partners rather than governments who have orders of magnitude more money and different kind of requirements about what their things look like and how they feel and how they work. Can come on board and say, well, actually, for $1 million a ton, we can actually start talking to you about how we go about building a bagger 293, which is like a 15,000 ton Jawa sand crawler with a giant bucket scoop on the front that is used in coal mining, right. And get it up on Mars and do some serious mining up there, because we just have to think about how we're sealing bearings and how we're managing electrostatic discharge and reduced a pressure environment and stuff like that. But it's not the sort of situation where you'd have to go and take a bunch of engineers who specialize in making earth-moving equipment and say, okay, well, forget everything you've ever known. Now we have to work with titanium, or now we have to we have to machine everything out of a cubic meter solid billet of aluminium to begin with, and so they can start thinking about, we water jet and weld stuff, like normal people. And this is one of the reasons that I think that reducing costs by a factor of 10 will increase activity by a factor of 100 or more, because there's just so much latent capacity across worldwide industry, but particularly in the United States, that can really address this market once it's opened, once it's available. Because previously, no private business would be like, oh yes, we're going to no large, very very large logistics focused business would be like, oh yes, and we're going to have a space division that specializes in doing stuff at 1/1000th the speed and 1,000 times the cost as the rest of the business. There's no synergy there. Or maybe there was in the past, but didn't Kellogg have a space division at one point?
I have no idea. That's crazy.
One of the breakfast cereal companies was involved in space at one point. Scott Manley has a video about it. It'd be really, really cool to see that. I think it's a really important thing for industry as well, in that it'll provide a way of taking engineers, like clever engineers, and spreading them throughout the industry and allowing them to do really cool stuff that they're strongly ideologically motivated to do, as opposed to what we're seeing right now, which is that Elon basically gets his pick of the best engineers graduating, no questions asked,
right?
Which is good for him, but I'm sure everyone else would like to have a go as well.
I do love this idea of a spaceport with a bunch of starships with their mouths open like humpback whales, just waiting, and there's just like a ramp and engineers are just coming up and just parking their rover inside, and you've got all the Pluto folks just filling up the spacecraft with various Pluto rovers and landers and hoppers and flyers and etc. And the Titan helicopters and sailboats and zeppelins and right. And you can just imagine that. And if you're a university and you want to go ahead. There's room in the back, right? And then it all just going to get disgorged. It's going to land, and then it's just all just going to pour out of this rocket onto the surface of Mars or Pluto or Titan or whatever. And
we get launch window to Pluto every year. I mean, like, we get launch windows to most of the planets, the outer planets every year because Earth laps them, and the inner planets like 2 or 4 times a year because they lap the Earth. It's only Mars that we have to wait 2 years because we're so close in orbital synodic period.
Yeah, like I think you've got.
But all the other ones you can go every year practically.
Yeah, and Venus I forget, it was like several months, 8 months.
200
or
days.
Something. Yeah, and Mercury similar. So to the Sun, everywhere, like just everywhere.
You can go to the Sun anytime you like. You can go to Mercury 4 times a year.
You could
go to the Moon.
I mean, it's hard
twice
to
a day
get to
if
the
you want.
Sun. Yeah, I guess so. Yeah. It's a bold vision. We'll talk in. I'm sure we'll talk in a couple of years from now and sort of see how much of this is starting to play out. But you're going to have to code a lot faster if you're going to be supporting multiple missions to many different planets across the solar system. It's you're making some more work for yourself is what I'm saying here.
Oh, I mean that's why I get out of bed in the morning.
It's no
problem.
Casey, if people want to follow what you're working on, where should they go? What's the best place to sort of keep track of the ideas that are percolating in your mind?
I post on Twitter pretty frequently. I'm at CJ Handmer. That's Charlie Juliet Hotel Alpha November Delta Mike Echo Romeo. And I have a blog, which is blog.caseyhammer.com.
And
the
blog is
the place to start.
Yeah, I want to stop you and sort of really emphasize how good your blog is and how how much original thinking has been brought to bear on, and a lot of it is very counter to the current trade winds of the space fans. So I mean, you're a space enthusiast, but you're also a bit of a countercultural space enthusiast as well, and I kind of appreciate that about the way you approach this, and have offered a ton of original ideas that I still like. Every time you make a new post, I'm all over it. So
I'm very flattered to hear that.
Yeah, no, it's good. I really appreciate this sort of very original thinking, and it's very entertaining, and you make a lot of strong cases that have resonated with me for the years since I sort of came across your work in the first place, and have sort of influenced my a much more a more realistic, I think, look at which things are going to work. And on the one hand, the things that are really going to take off when we're dramatically underestimating how much of an impact this is going to have, and then on the other hand, the stuff that everyone thinks is going to be big is probably not going to be big. So I appreciate.
I've had a few lucky guesses there, actually.
Yeah,
I was just looking back at what I've done over the last couple of years. I think I called it with the Starlink blog pretty early on, which I'll pat myself on the back about. But I also benefit a lot from readers, especially ones who jump on it straight away, being like, you fluffed this, you messed this up. And I'm like, oh, yeah, no, fix. No one will ever know. And the thing is, like, the whole reason I write the blog is that I'm trying to promote a kind of an ideal or a concept of how discussions in space could be made. Mm-hmm. And really, a lot of the subcultures in space are very much, slightly walled gardens or kind of appeals to authority, mm-hmm. or just like thinking that is less first principles and less rigorous than I would like. And I feel like if I lead by example and I talk about things in a positive light for the most part, and really kind of show my working, that I can do that. And then if people are like, I don't understand this, you seem to just pull this out of your ass, I'm like, okay, I'll write another blog on that, actually do the math.
Yeah.
You asked for it. Here's a graph. Here's another graph.
Yeah. But I think it's great. I mean, I think that we're at a time now where more people need to understand the nuances. Like we can't just get excited about about people going to the moon or people flying to space. Like, it's time to understand the costs, the benefits, the risks, and what the future holds, because it's going to start having an impact on our lives. And I think that's the role that you're starting to play, is like, just sort of grabbing people and shaking them and saying, take this stuff seriously. Here's how it's probably going to play out. And I think it's really fun. So I put a link to the blog in the show notes, but definitely check out Casey's blog. And, if you ever decide to do like a podcast or anything, I think people would love it. So, but
I'm just a podcast leech. I just go on your show.
Yeah, exactly. So. Yeah. Awesome. All right. Well, thanks, Casey. And I'm sure we'll talk in a couple more years as more of your predictions come hauntingly true.
Or wrong, either way. I don't know.
Or the wrong, yeah. Sure, either way, yeah. All right. Thanks a lot, man.
Cheers.
Thanks, everybody. I'm ending the stream.